Today we are going to see test for a specified mean. In t-test. Given a random sample of size n is less than 30 with sample mean x bar and the population standard deviation is not known, and we want to test whether the population mean has a specified value then we apply the same procedure as the case of large sample. Case 1, two-tile test. Null hypothesis H naught mu equal to mu naught. The alternative hypothesis H1 mu is not equal to mu naught. On the assumption H naught is true, the test statistics T is equal to x bar minus mu by s by square root of n, where s squared equal to n by n minus 1 into s squared. S being the standard deviation of the sample. This t-test follows t-distribution with number of degrees of freedom n minus 1. For a given significance level, if the calculated value of t is less than the table value of t, H naught is accepted. If the calculated value of t is greater than the table value of t, H naught is rejected. Here the table value t is got for a given alpha for 5% or 1% level of significance. Case 2, one-tile test. In the case of one-tile test, the null hypothesis and alternative hypothesis may be classified is one of the forms. H naught mu equal to mu naught, H1 mu is greater than mu naught, or h naught mu equal to mu naught, h1 mu is less than mu naught. However, in this case, the table value of t for a given significance level alpha, 5% or 1% level of significance, the conclusion is drawn on the same line as in case 1. Example, a machine is designed to produce insulating washers for electrical devices of average thickness of 0.025 centimeter, random sample of 10 washer was found to have an average thickness of 0.024 centimeter with a standard deviation of 0.02 centimeter. Test the significance of the deviation value of t for 9 degrees of freedom at 5% level is 2.262. Solution. Here mu given, mu is 0.025 centimeter and n is equal to 10. So degrees of freedom n minus 1, 9. X bar given, x bar is equal to 0.024 centimeter and s given, s is equal to 0.002. Since n is less than 30, the sample is a small sample. So we can apply t-test testing the mean. H naught mu equal to 0.025. The alternative hypothesis mu is not equal to 0.025. So the test statistics t is x bar minus mu by s by square root of n minus 1. That is equal to 0.024 minus 0.025 divided by 0.002 by square root of 9. Use calculator, that value is minus 1.5. Therefore, modulus of t equal to 1.5. Degrees of freedom, n degrees of freedom. The number of degrees of freedom is n minus 1. is n minus 1. So 10 minus 1, that is 9. The total value of t for 9 degrees of freedom 5 percentage level of significance is given, that is 2.262. So H naught is accepted at 5% level of significance, since the calculated value of t is less than the table value. Therefore, the deviation is not significance. Given question, test the significance of the deviation. So our conclusion, deviation is not significant. Another example, a soap manufacturing company was distributing a particular brand of soap through a large number of retail soap before a heavy advertisement campaign. The mean sale per week per soap was 140 dozens. After the campaign, sample of 26 shops was taken and the mean sales was found to be 147 dozen with a standard deviation of 16 dozen. Can you consider the advertisement effective? Solution, mu given 140 dozen, n is equal to 26, x bar given 147 dozen and s given 16 dozen. Since n is less than 30, so it is a small sample. So small sample. So hypothesis, mu equal to 145 dozen The alternative hypothesis is mu is greater than 140 dozen. Here we can use one-tile test. So T equal to x bar minus mu by S by square root of n minus 1. So 147 minus 140 by S is 16 by square root of 25 minus 1. So that is 26 minus 1, 25. That value is 7 into reciprocal 5 is by 16 equal to 2.1875. So degrees of freedom n minus 1, that is 25. The table value T for 25 degrees of freedom at 5% level is 1.708 from the table. Conclusion: H naught is rejected since the calculated value of T is greater than the table value of T. This means the sales have increased after advertisement, and hence the advertisement is effective. So another example, 5.1, 5.4, 5.2, 4.6, 5.1, 4.6 and 4.7. Test whether the machine is working properly. Solution: the sample size n is equal to 10 and mu equal to 5 kg. So first calculate x bar and s. Here the data given, so we can use x equal to 4.7, 4.7, 4.7, 4.9, 5, 5.1, 5.4, 5.2, 4.6, 5.1, 4.6, 4.7. So we need to find out x squared. 4.7 the whole square, that is use calculator, 22.09, 24.01, 5 is 25, this is 26.01, 29.16, 27.04, 21.16, 26.01, 21.16 and 22.09. So just find summation of x, that is 49.3 and summation of x squared, use calculator, 243.73. First find x bar. X bar is summation of x by n, that is 49.3 by 10, that is 4.93. Next find out s. It's a formula, summation of x squared by n minus sum of x the whole squared by n, that is square root of 243.73 divided by n minus sum of x the whole squared by n, that is 4.93 the whole square. So use calculator, that value is 0.27. So take null hypothesis mu equal to 5 kg. The alternative hypothesis mu is not equal to 5 kg. Now test statistics is t equal to x bar minus mu by s by square root of n minus 1. So for 4.93 minus 5 divided by s is 0.27 divided by 9, square root of 9. Because n is 10, so this value is minus 0.07 into 3 by 0.27. Use calculator, minus 0.78. So therefore modulus of t is equal to 0.78, and degrees of freedom n minus 1 is 9. Use the table value of t at 5% level of significance for 9 degrees of freedom is 2.262. Use calculator. Conclusion, H0 is accepted at 5% level. Hence, the machine is working properly.